Hello, everyone. Thanks for joining in wherever you are. Just like to say a big thanks to the organisers here at WFH Conf and Nearform and everyone involved in it. It's a very cool experience to be involved in something like this. So I'm Chris Laughlin, and today I'm going to talk about protecting your NPM dependencies and just general NPM security. So let's get started into it. So again, who am I? I'm a JavaScript developer. I work for a company called Rapid7. We work on my security products. So I work on a web application scanning tool. It's a tool that scans web apps, which is very meta. So today, as I said, I'm going to talk about NPM dependencies and how we can improve security in and around these. But first, I want to start off with a little bit of a story. So it was sometime last year, I was rudely awakened in the middle of the night. It was about 3 a.m. Pager duty had triggered a bunch of alerts. On checking my phone, I could see we were getting alerts from Amazon saying that all of our Amazon instances were running at full CPU usage, which was obviously going to mess up our monthly bill. Our QA team were sending messages to me saying that our site was running low and being very unresponsive. We were getting alerts from third-party vendors flagging our own product as a security vulnerability and saying that we had malicious code on it. And people were noticing, including customers, that there was strange network activity being sent off to different third parties on sites that we didn't have any control over or connection with. So I frantically jumped out of bed, ran to my laptop, started logging in, checking all of our services. So first things first, I kind of checked to see, was anything deployed in the last few days? Had we released any new code? No. So then I decided, okay, I'll pull down our current build, run it on my machine. Everything was looking fine. So the next logical step was to redeploy what happened last night. And on checking it, everything was still failing, still running slow. Our Amazon account was still full CPU usage, still getting this weird network activity. So it was at that point we decided to call it a night and give up. We took down our web application, put up a banner saying we were closed for business, and decided let's regroup and investigate this in the morning. So what had happened here? On further investigation the next day, we discovered that a third-party NPM package that we use for code transpilation, so taking the likes of ES6, ES7, this new future code, and transpiling it into code that browsers can understand. It had been injected with some malicious malware, and as part of this, it was interfering with our code at build time. So as our product was building on our CI/CD server, this malicious code scraped all the environment variables from our CI environment, including the likes of Amazon tokens, NPM security tokens, any other security tokens, anything secrets that we don't want to expose whenever we're building our product. Because the code was involved with transpilation, so it was changing the way we had written our code into more understandable code for browsers. It was able to inject keyloggers into anywhere that we were building and rendering forms, which explains this weird traffic going off of different servers. It was also able to add in crypto miners into our code base, which then explains why the site was being slow and sluggish for different users. And on top of that, because the attackers had scraped all our environment variables, they now had access to our Amazon account, and they were running crypto miners on all of our AMI instances, pushing them all to max CPU, costing them nothing but reaping the rewards. Although I have a confession here to make. Everything I just said was completely made up. This didn't happen to us. It could have happened to someone else, but it's probably not been reported. Unfortunately, with the current state of NPM and JavaScript security and the way that we use this ecosystem, instances like this could happen and may have already happened but not been reported. But thankfully, this never happened to us. So enough scaremongering and putting the fear into people about using NPM packages. Let's take a look at some instances that actually did happen that we can analyze and look on and learn from. So I've kind of built up a little timeline here of different instances that happened. There's 3 kind of important ones that I feel that we can dig into and look at. So the first one is in and around this package, CrossEms. So if you've never heard of CrossEms, it's a utility package that deals with environment variables. So it allows you to work with environmental variables across different operating systems, be it Mac OS or Windows. For each of these, we're going to break down the kind of post-mortem, if we like to call it that. We want to look at when it happened, the impact, the aim, and then the entry point, and then we'll follow up with some ways that we can protect ourselves against this. So this was discovered in 2017, so quite a while ago, but it's still important to how this ecosystem is growing. The impact, so at the time, this package was getting roughly 700 downloads in total. However, the same attack, which we'll learn about soon, was used on 40 other packages in the NPM package repository. And the aim here was to steal environment variables, kind of taken from the package deals with environment variables. This was to steal this. So it would harvest up your environment variables at build time and then send them off to a malicious actor. And the entry, which was quite an interesting entry point, was typo squatting. So if you're old like me, you remember the days whenever domain names were becoming the whole big thing, and people were then registering domain names with extra letters. So BBC, but with 2 C's, and it would take you to some dodgy website that you most likely shouldn't be looking on network. And this is the same case here. Someone had registered a package of cross M's. The legitimate package is cross dash M's, but you wouldn't say the dash when you're talking to someone in person. So chances are people would accidentally download this package instead. So how can we protect ourselves against this? So we got 2 methods here. First one is check the package information. It seems quite simple, but have a look at an NPM package before you install it. Have a look at who the author is. Check the links to the GitHub repos. Have a look at, was there any recent releases or commits? Is it a well-maintained package? Is it a legitimate package? And if you're inclined, look at the GitHub stars to see if that's a metric for yourself as well. And then the second point is this is when NPM really started kind of thinking more about security and introducing it into their pipeline. They decided to add their own name checks against packages. So if you try to publish a package that has a very similar name to an existing package, it will be rejected. Now, you can contest this, but this is a good way to check against this. So like if you tried to register Angular with 3 Gs, it would probably reject that. So this kind of blocks against that. And then kind of moving along, so the next one is a package called Event Stream. So Event Stream is a package for Node that deals with data streams, and it's like a really good utility library for managing them. This was discovered, again, about a year later in 2018. Now, quite a large impact in this one. So we're looking at roughly 1 million weekly downloads of this package. It's a very popular, well-used package. It's always one of those things that's used by a package, but used by a package, used by a package. The aim for this was to steal Bitcoin wallets from a company, Copay. So kind of targeted thing on this imaginary currency that everyone loves. I got into Bitcoin whenever it was at the highest price, so I lost all my money on that. I'm very bitter about it. And then the entry point for this is a really interesting one. So it was literally that the maintainer of EventStream handed over the keys to the kingdom to this malicious actor, because the maintainer for EventStream had moved away from it, wasn't using it anymore, didn't want to maintain it. Someone else came along and said, I want to take this on, improve it, and grow it. So they passed on that, but also that gave them this reach of 1 million weekly downloads that they could then pipe down malicious code. So how do we protect ourselves against this? So ensure that you lock down your packages. If you're using one of the latest or even a few versions back of NPM, and if you're using Yarn, it'll come with this package lock system in place. So you can lock down what versions of package you're using and always hard set the version in your package.json file. So it hasn't got that little caret symbol, which is going to give you those minors and patches for free. The way I look at it, you're also getting malware for free, potentially. And the second one is really kind of an open-ended protection ability. Is like we need to start rethinking how we manage package ownership in the community and open source in general. The person in this case didn't want to maintain this open source project for the rest of their life. I wouldn't want to work in a job and not get paid the rest of my life. So why would people potentially maintain and manage open source projects for the rest of their life? And it's how do we compensate open source contributors, but also how do we maintain and manage the communal effort on the stewardship of these packages and passing over ownership to different people. And this is something that the community itself is going to have to build upon and grow, but there's definitely room here to add security checks and measures in place to prevent these kind of actions happening again. And then we'll move on to our last incident. So this is around a package called Electron Native Notify. So this is a small utility wrapper around the Electron notification API. As you can kind of see, there's a trend. These are all small utilities that people may use for little functions but never think about them. So this was actually discovered last year. So this is the most recent incident that I've seen. A very small impact again. Only 600 weekly downloads, but it was a targeted attack. So the aim here, again, stealing this imaginary money, as I like to call it, but it was targeting a company that used this NPM package. And this was a kind of interesting one where NPM had worked with the company to help in the prevention of $13 million worth of cryptocurrency to be stolen, because they were attacking Bitcoin wallets, knowing that this company used this NPM package, and they were able to inject malicious code into it. And in the entry point, it was as simple as someone had managed to get access to the Electron Native Notify package and release a small version of this already trusted dependency. And then whoever was maintaining this Dash or Bitcoin wallet software was automatically updating to this new version and not knowing that they were getting this malicious code. So how do we protect ourselves again? So we can kind of see there's a bit of a trend here. Lock down your package versions. If you set your package version to be 1.0.1, you're always going to get that code from NPM. Once something's been published, NPM cannot be changed. So saying that these are the versions I want to pull down, you'll always get that same code every time. Never have wildcards or barriers in your packages. Always hard lock your packages. Use package lock files. Use the package JSON to hard set your versions. So we've kind of looked at some instances that happen, but a lot of this is kind of maintaining a lock file and this kind of thing, or manually checking. There's some tools and workflows that we can use to our advantage in this. So easiest one to use is npm audit. If we're using npm version 6 or above, it comes pre-installed. It runs after every npm install, and it gives you an output of what vulnerability or what packages are vulnerable that you're dependent on. It's kind of nice that it covers all your bases. It also has its own autofix command as part of its CLI. So you can tell it to autofix all your versions. So it'll just bump up the versions that it knows are safe. Now, in some cases, take that with a pinch of salt. If you're like me, you're using an old version of a package because it only works in that version. And if you wanted to upgrade, you'd have to rewrite your entire product, and nobody's got time for that. So take it with a pinch of salt, use it as a kind of advisory. So when you run it, you get this kind of output, so you can kind of follow along which packages you need to update, what are the broken versions, what are the vulnerabilities involved in this. But npm audit's great, but it's very set to being I'm working in the terminal. So there's other tools as well. So there's this great company, Sneak, and they are a cloud-based solution to this. So they can integrate with your source control, so be it GitHub or all the others. I only use GitHub. What I really like about this is it's not just you're running through the terminal, because that's a very manual process that the developer has to do and maintain. Where this is connecting directly to your source code, it scans your package JSON file, and then you can schedule these scans. So it can be done, through your CI/CD pipeline, or it can be just done on a weekly basis, or you can trigger on-demand scans if you know that you're changing things, or new vulnerabilities appear. So vulnerabilities are not always known all the time. And it also gives you some really nice reports. So you can see here I have 23 active in inverted commas. My side procs are never active. How many vulnerabilities I have, and a kind of really nice looking dashboard to show all the different active projects that I have, and what the vulnerabilities are, so I can see like a good health of my products, whether they're really at risk or have a little bit of risk, and know which ones to tackle first. And then lastly, this is kind of like the one that most people will get a lot of the benefit and advantages out. Most people are using GitHub to maintain their source code. It now has its own built-in dependency checker, so it's doing something similar to Sneak, and it's checking your package JSON file, going through, checking all those dependencies, checking if there's known vulnerabilities in them. But since GitHub acquired Dependabot, they've also built in the ability to do automated PRs to fix these. So that kind of takes a bit from that NPM audit, but has a audit and pipeline. So now you can create a PR, it can get peer reviewed, your team can know what's going on, instead of just one developer fixing it manually every time. their database of vulnerabilities is growing constantly. So they're being more aware of different vulnerabilities that they can be aware of and tackle and alert the customers. And now with the new changes of GitHub with their own package repository and then their recent acquisition of NPM itself, there's a potential to link a lot of this together. I haven't seen too much on the security side of things of how they're going to maintain and manage this, but one potential would be for GitHub to do almost a reverse engineer on the source code in NPM compared to your actual committed code in GitHub. The one thing I always note is I could publish a new version of a package from my laptop now. That doesn't mean that the code that's in NPM exists in that GitHub repository. So you bypass that peer review line, you bypass all that kind of sanity checks that people could catch these vulnerabilities, and it's having to try and think of an accountability on that kind of scale. So maybe there is potential to catch it at the source and then being able to verify the code. And we can kind of see here, so this is the view. I have a purposely vulnerable repository that has a bad version of jQuery, so you get a big banner to kind of tell you something's wrong with your project, you need to address this. And very similar to the NPM audit screen, you get a detailed view of like, okay, to fix this, upgrade to this version, and here's some of the links to the CV information and external sources to explain the details of that vulnerability. If you're security inclined, you can dig into that and look into that information. So kind of wrapping up and getting near conclusion here. So should we stop using NPM? No, of course not. NPM is this great resource that people take advantage of every day. I like to think of it like you could build a fully functional application with writing maybe 10, 20 lines of code, but by reusing all these other packages to help build this hugely functional product. And it's the whole analogy of like we're standing on the shoulders of giants here. NPM is, I guess, the giant's shoulder, and we're standing upon it. So it's a great resource. Yes, it's not perfect when it comes to how we maintain and manage security in it, but I'd be stressed to see other repositories trying to tackle this too. Should we start using lock files? If you've been paying attention, you'll know the answer to this is yes, of course. These lock files help you to reason on and assert what code you're getting. You're always getting that code every time. These are not perfect though. So there was a developer who works for Sneak who recently released a blog post talking about how you can fool someone into thinking that you've updated a package to a trusted version and a trusted location. But by modifying the package lock file, because you can tell it the URL of where to go and fetch the code, with GitHub's different system, sometimes it'll just blankly ignore diffs or hide diffs in lock files. So there is ways around that, but as these things progress, people will be able to try and fix these a bit better. So, okay, lastly, should we think twice before using NPM packages? Yes, of course. I always like to think of the analogy of if I sent you an email to everyone on this conference with a JavaScript file attached to the email, you wouldn't blindly take that file, put it into your product, and then push that to production. But in essence, we're doing something very similar when we use NPM. We're pulling down the source code written by someone we don't know. We don't know their background, we don't know their skill level, we don't know how much they care about security or if they're malicious at all. And we're pushing that code into production and serving that to our users. In reality, when we build applications in the modern way that we do, we write 20% and we take 80% from NPM. So 80% of the code we ship down the line to our customers isn't our actual code. We can't assert on it, we can't reason on it, we can't justify that this is secure and safe. And we need to start thinking how we maintain, manage, and build security. And I hate red tape like everyone else. I don't want to have to be putting vetting processes in, but using common sense, building up checks, getting these tools, we can bring those all together to make sure that we're building a safer, stable product for our customers. Thank you very much for listening.